For the graph on the grid below, approximate the instantaneous rate of change at x equals 2 and x equals 6. So at x equals 2, we're at this point here, and what we need to do is draw on a tangent to the curve. So if we do that, we use a ruler and we draw a nice straight line that goes through that point, touching the curve only once at x equals 2. So there we've got a straight line at x equals 2, which is a tangent to the curve. And what we're going to do now is find 2 points that line that line and then calculate the gradient of it. So if we have a look here, we can see that this point is approximately 0.8 and 11 as the y value, and we're just picking random points that are easy to identify. And another point, if we look along the line, occurs at this point here, which is 4, 6. So at x equals 2, we have the gradient of the line is equal to y2 subtract y1 over x2 subtract x1. So that's the formula for the gradient. And if we put in our values, we're going to have 11 subtract 6 over 0.8 subtract 4. So the top line 11 take 6 gives 5, and the bottom line 0.8 take 4 gives minus 3.2. And we can simplify that to 25 on negative 16, and that as a decimal is negative 1.5625. So that's the instantaneous rate of change as approximated by the gradient of the tangent at that point, x equals 2. We're going to follow the same process for x equals 6. So here's our point on the curve here, and we're going to draw a tangent using a ruler to that point. So there's our tangent line, and what we're going to do is again select 2 points that lie on the tangent line and use them to calculate the gradient of the tangent. So if we have a look, at 5, the y value is negative 3. And then if we continue along that line, at 7, the y value is approximately 9. So using those 2 points, we're going to calculate the gradient of the tangent, which is y2 subtract y1 over x2 subtract x1. And now y2 is 9, subtract y1, which is negative 3, over x2, which is 7, subtract x1, which is 5. So evaluating the top line, we have 9 plus 3, which will give 12, and 7 subtract 5 on the bottom line, which will give 2. So we can say that the approximate gradient of that tangent line is 6, which is the instantaneous rate of change at that point.